I want to welcome everyone and thank you for joining the Rocana webinar, Control Your Modern Infrastructure. My name is Michelle Howling and I'm Director of Marketing here at Rocana, and I will be your host today. Also joining us as co-host is my colleague who has up product marketing, Tom Yates. Today's session will be recorded, so if you do miss any part of it, playback will be available tomorrow. We will take questions throughout today's session, so if you do have a question, please direct those to the host and to the presenter using the chat feature. Or if you have any general questions, please do send those in as well. So without further ado, I would like to introduce Rocana's CEO and co-founder, Omer Treiman. Omer?
Thank you, Michelle.
Wonderful.
Thank you, Michelle, and welcome everyone. We're really excited to be talking to you about Rocana and our flagship product, Rocana Ops. To give you just a little bit of background on the company, Rocana was founded by myself, John Brown, and Eric Sammer. We all met up while working at Cloudera, and they're helping people adopt big data technologies like Hadoop. We also realized while working with customers that a big challenge in adopting next generation IT technologies such as Hadoop, but also technologies like OpenStack, Docker, Mesosphere, Cassandra, was really on the operational side. There's lots of tools today that people can use to take advantage of technologies like Hadoop and others, but it's the operations team who have to actually keep the lights on, keep this technology running, integrate it with the legacy systems that they have. That's where people were struggling. And that solving that problem for customers while at Cloudera was really the inspiration for founding the company. To give you a more specific background on the problem space that we found as we started digging in with early customers, we saw that IT has really undergone a paradigm shift. If you go way back in the day to kind of the 80s and 90s, right, the pre-web era of technologies, usually IT had a handful of boxes, and usually they were blue, right? There's a big mainframe, it runs most of the business. You can imagine, and these still run today, you walk into a bank, you talk to a teller, you go to an ATM. That's a very self-contained piece of infrastructure and set of systems that IT knows how to manage, and there's plenty of technologies, good technologies today to operate and manage those systems. When web came along, people started deploying a lot of single-purpose servers. You'd have specialized web servers, you have application servers, specialized database servers that grew into the hundreds, maybe even into the thousands as people started to virtualize. But the workloads were still static. It still required a next generation of operation software for IT. The software that worked for the mainframes didn't necessarily work for the next generation of software. And then what we've been seeing recently is really this sea change that's going on. And I think most critically, it's gotten to the point that servers are no longer unique. They're no longer distinctly identifiable as long-running systems. When you spin up a container, when you spin up a VM, it could be on any host. It could be connected to any switch within, say, a private cloud infrastructure. And all of this is very dynamic, very elastic. And there's multiple constantly changing workloads. You'll find situations where the same hardware has constraints based on completely unrelated workloads that happen to be co-located or happen to be accessing the same shared object store. And that happens temporally. It's something that will take place. You'll see a glitch or a hiccup, and then it'll disappear. And this is a whole new world of operating. Most significantly, what's happened now is that the systems no longer fit in someone's head or on a whiteboard. It's very difficult, and in most companies now, it's becoming impossible to actually map out what an architecture looks like, and this is creating havoc from an operations perspective. And so what we've done at Rocana is we've actually looked at how people manage these kinds of workloads and come up with a solution to that. The three things that we noticed that are challenging today that we've addressed with Rocana Ops. The first is that most monitoring today, most of the solutions that have been adopted with new infrastructure technologies over the past decade have been very siloed. There are separate systems for collecting log data and doing analytics. There's separate systems for monitoring metrics. There are separate systems for application performance monitoring. There are separate systems for network performance monitoring. And so each of these solutions is geared towards a different audience, a different group of system administrators. And when a problem happens, they all look at their view of the world, and theirs looks fine. And so there's a lot of sort of, it's not my issue, it's not my issue. Everyone's kind of pointing fingers at everyone else. And the reason for that is everyone's looking at different data. It's all little silos. These solutions also require that you know what you're looking for. And so if there's a problem, say the APM system flags a performance issue, you don't necessarily know what's caused that. And so it's basically looking for a needle in a haystack across every single piece of the system. And finally, what we've noticed is that most of these systems were designed when there was much less data coming out of IT infrastructure, and there's just much less infrastructure out there. And so it was a lot when you had 100 gigabytes a day from your entire infrastructure. And today people are talking about a few terabytes, and that's where these systems are really creaking, but they're projecting 10 times that over the next few years. And that just requires fundamentally a different way of thinking about how you collect, store, analyze, and visualize data specifically for IT operators. And so that's just kind of big picture of the space that we've seen and that we've heard from customers. What we introduced, and this was just a few weeks ago when we announced our flagship product, is Rocana Ops. And I'm going to talk about the architecture for Rocana Ops and different aspects of it, and then show you a little bit of what it looks like and an example of how you would use it. So there's three things that we designed Rocana Ops to tackle. The first is this concept that we call augmented IT operations. And if you're familiar with DevOps, this idea that operators rely much more on automation. They kind of have more of a developer mindset, and developers have more of an operational mindset. I think the reality is that it's a rare breed that has sophisticated sort of PhD level computer science knowledge of these systems and is going to carry a pager. There's a handful of companies in the world that can hire those folks. In most organizations, you have specializations within operations and within development. And so the idea behind augmented IT operations is taking a lot of the concepts behind DevOps, using big data technologies, advanced analytics, machine learning, and visualizations to present those and enhance what today's IT operators, what they can do. And what it ends up doing is delivering sort of a faster triage out of the box. You don't need to know what you're looking for. You don't need to design custom dashboards. You have a lot of flexibility in the system, but really the system just tells you what's going on and what's wrong in a visual manner that really guides you to the root cause of any particular problem, if it's an operational issue or if it's a security issue. From a scalability perspective, the technology we're built on is designed and proven to handle tens of terabytes a day. These kinds of systems we've seen live scale to over 0.5 petabyte a day on global data infrastructure. So it can handle the data volumes of today and tomorrow, and integrates with products that are very purpose-built. So you're still using a specific security product with all the rules you're baked in. You're still annotating and instrumenting your application infrastructure with APM. You might still be using analytics solutions to tackle subsets, but you have a feed of everything that's going on. And then in concert with this, you know, these products aren't built and shipped in a vacuum. We know that a big challenge today when we're talking about this scale of data is just total cost of ownership. We've seen monitoring solutions that cost more than the systems that they're monitoring, between software licensing costs and hardware requirements. And so what we've done is used a lot of open standards and open architectures under the covers. It's a very cost-effective way to build the back end of the system. It allows you to use the data for multiple purposes and price it per seat. If you have 5 or 10 people using it, you pay for those people. It doesn't matter how much data you're collecting. It doesn't matter if you see a spike in traffic. So those are kind of the concepts that we use to feed into Rocana Ops. From an architecture perspective, I'm going to walk through sort of each of these pieces. There's really three logical components to what we're building. The data collection piece is where we pull data from everything. We pull data from syslogs and log files and metrics and APIs. That goes into what we've been calling an event data warehouse. Sort of similar to the enterprise data warehouse that you use to collect all your business data, but this collects all the events, everything with a blinking light that can send information within your infrastructure goes into the event data warehouse. There's a bus that collects all that data and feeds it to a variety of different systems. We do built-in transformations on that. We aggregate the data as well as storing detailed data. We handle all the data lifecycle of that, so you can decide which data you want to store when. This is fully secure enabled. It uses Kerberos and connects back to Active Directory, so you can put in sensitive data and secure it and guard against unauthorized access. And we also apply analytics and machine learning to that data as it's streaming in. And you can tap into that stream. We also allow you to access that data as it's stored. And then the Rocana Ops product actually presents it with purpose-built visualizations that I'm going to show you in just a few minutes. So walking through kind of detailed on the architecture, of course, the first question usually is, well, what can you collect? And the answer is, well, really everything. Some of the stuff comes out of the box. So anything syslog, if it comes on the network, application logs, web server logs, database logs. There's some future work we're doing to tackle other network-based data feeds. But basically, if you can put an agent on the box or you can get the bits off the box in a standard format, we can collect that data, parse it, and store it. As well as store the full fidelity, sort of the original data feed, as well as metrics. And metrics are both sort of CPU load, memory usage, disk, network, sort of machine or host level metrics, as well as feeds from other systems. So if you are running an APM system, you know, an AppDynamics or New Relic or BMC or CA, you want to feed us that data from that part of the system. That can go into Rocana Ops and be correlated with all the other feeds that you have, all the logs you have from the rest of the stack, as well as discrete events. So if you rebooted a system, you're using a ticketing system to track you know, sort of discrete events or manual events. We can collect those and annotate and automatically insert those into the feed so you can see when different actions are taken. If you have a security system, a SEM solution with a set of rules, it's sending out alerts, and you want to overlay a potential security event with all the logs from all the infrastructure that you have globally, you can feed that into the system as well. And then, of course, we haven't thought of everything. There's new systems coming out every day. There's a whole bunch of data that you might want to feed into this. Blacklisted IPs, you want to feed in reference data sets, host name mappings, username mappings. We have open APIs for that. There's native Java APIs. You can send it REST data. Everything's encoded in the wire, which is the schema format for the data. And so you can really send us everything, whether it works out of the box or whether it's a custom system that you built. So all that data gets collected into this event data warehouse, and it runs through the event data bus, which means you can tap into it on the wire within milliseconds of an event being produced. And we apply various transformations and aggregations, analytics, and control the data lifecycle and duration of the data as it's stored. The transformations, for example, we can pull data from the message that is sort of semi-structured or even complex binary formats and promote those into first-class attributes that you can build for use as derived metrics. So for example, HTTP codes or response times, transaction IDs, or latencies from recorded latencies from any servers, from any systems. We aggregate that data, so you effectively get really fast slicing and dicing. Think of it as a sort of a massive OLAP cube of everything that's happening across all of your infrastructure. And we also apply machine learning and anomaly detection to that data to be able to annotate where things might be going wrong and where you might want to pay attention to that data. So I talked a little bit about this, how much data can this system handle? And we're happy to kind of give you specifics when you're talking about your data feed. These are not necessarily large systems that you need in order to handle masses of data. The solution is really built to handle pretty much as you've got. We haven't seen anyone throw data at us or even in their plans, in their long-term plans, that we can't provably handle. You know, most systems today, if you look for comparison, kind of start you off at a few gigabytes. Maybe they peak at 100 or 500. We've seen people push some of these systems to a few terabytes. I mean, for order of magnitude scale, we're talking 10 plus terabytes a day into maybe a dozen or two scale-out servers underneath that are actually handling that. So you could actually handle in a rack or two pretty much all of your infrastructure globally if you say you're running a half dozen data centers. And then finally, I wanted to mention just a little bit about the integrations. We know that there's lots of downstream systems that people use today that they've built custom rules, custom dashboards in, but you don't necessarily want to feed the fire hose. Those systems may not be designed to store full history. They may not be designed to handle that volume of data from everything. And so while you're collecting it all and you have visibility into everything, you can tap that and either on the wire or in batch, depending on how you want to feed the data in, you can actually connect to many different third-party systems. A lot come out of the box. And of course, because all the data formats are open, it's very easy to add capabilities for new third-party integrations or to custom systems. We've actually had, in some cases, customers who will build their own rules on top of that using standard technologies. So either through the public subscribe mechanism, which is Apache Kafka under the cover, or using SQL queries. Any SQL over Hadoop system can access the data. It's stored in Parquet files, which are sort of an optimized columnar store map on top of HDFS. And we've also had people feed in reference data, which you can combine with the data to show in the Rocana Ops visualization or to combine and transform, again, using third-party tools and publish that up. So I've talked a lot about the architecture, the data flow. I know you're dying to see the product. What we've done is actually just walked through sort of a very straightforward scenario, something that that fits in a demo time frame, and taken those screenshots as we did it, so you can actually just see visually what the product's doing. And I'll describe a little bit about the different capabilities of it. So when you log into Rocana Ops, one of the things we noticed and built as a core feature of the system is you don't need to actually tell it anything or configure anything. Rocana Ops has built-in knowledge of how data centers function. And so as soon as you start sending it data, it lights up. It's already analyzing that data and looking for what's very active in your system, what's in your data center, what's not active, which systems are talking a lot, what's fluctuating wildly. And what we do here is we show you initially just basic volume of data as a proxy for system health, right? The more regular the volume, a system is probably not changing its behavior significantly. But if the system all of a sudden starts talking a lot, that's potentially unexpected. Similarly, if the system has gone quiet, that's also potentially unexpected. And we actually do that at various levels in the hierarchy. We can do it by location. So your cloud-based system all of a sudden goes quiet. Maybe there's a connectivity issue. Maybe there's an outage at AWS. All of a sudden it goes really active. Maybe you're being hacked. You can do it by data center. You can do it by subsets. It's kind of up to you how you define sort of the physical location that you want to map. We do it by host. These are physical hosts and virtual hosts. You can monitor both. You can see activity, going really crazy on a physical host and one virtual host and silent on the other virtual hosts. Then you've got sort of a resource allocation issue. That'll surface in this visualization without having to do anything. Just send it the event data and we will show you what's going on. And we can do it by service. So we can get you down to the level of, this is how my web servers are behaving. This is how my HTTP service is behaving. If you have a complex application with a lot of microservices, we're tracking all of those and showing you if there's large changes in behaviors in certain aspects of your platform services or your microservices. The other thing that we have, and I'm just going to highlight this, is our anomaly detection, which again functions out of the box. We can look at pretty much any metric. We show you by default volume-based anomalies, but you can have anomalies turned on to look at changes in behavior of CPU usage or memory usage or disk usage. All right, disk, classically, it's not really that the disk is 80 or 90% full that you really care about. It's the rate of change of how it's filling. If it goes from 50% to 95% within a matter of minutes, you almost don't have time to reply to into the warning bell saying that there's a problem with it. But with anomaly detection, it'll flag that early on as soon as it starts deviating from the process. In this case, we have sort of this obvious spike in a handful of anomalies that that were detected, and we actually can zoom in. The panel, it's a little obscured, but I've got a blown out version of that. Underneath it will actually tell you what it is. Which metric did it happen in? What service did it come from? Where was that location? What host is it running on? What did we think was the value that it should be? So we thought you should have sort of 3.5 second latency, average latency from this HTTP request, and it's actually peaked, it jumped to 7 seconds, so the system actually flagged that. What you can do from there is start your investigation. Right. At the end of the day, you want to understand the root cause of any anomalous issues, anything that's going wrong within all of your infrastructure. And we have a few different views. You might click over to a performance dashboard if it's a performance-related issue, and start reviewing metrics for some of the affected hosts. And here, just kind of drilling down from the anomaly, you get useful debugging information. We tell you, again, event volume, memory, CPU utilization. You can really track any kind of metric that you want, and you can aggregate it by any aggregation means that you want, any aggregation function for any time period, for single hosts, for collection of hosts, depending on how you want to view it. And then, of course, this is a demo. So when you mouse over and we show you kind of the CPU usage for all of these, there's an obvious spike here, right? So CPU utilization for one of your application servers is out of whack with all the other servers, with your web servers, with your database servers that are sort of the top Even out of the top ones, this one's way above all the rest. The other thing that you can see here that's interesting is that you also have this other change CPU utilization, which is in the database server, right? So there's a few different systems that might be misbehaving here. And interesting that one of the database servers and the application server both peaked at the same time, and the application server significantly peaked. And so this is an indication of where you might want to focus, but it's not really clear. You haven't really ruled out what systems are having problems and what aren't, but it gives you another step forward of where you likely might want to consider. There's a separate view that you want to look at just to confirm that, right? So if you look at the HTTP request latency, you can just view those charts side by side, pull up that same metric that set off the alert. You can see that one of the web servers is fine, but one of them is actually spiked. So there's a very good chance that there's one web server talking to one app server, talking to one database server, and something in that chain is the problem. Right, and classically now, even if you had this view, pull up the APM system, pull up the log analytics solution, pull up the database monitor, you're still going to be looking at 3 or 4 or 5 different views of the data, each of them with different time frames and different axes on their charts in order to understand what's going on. Instead, just staying within Rocana Ops, you can take another slice of that data and say, well, let me rule out, can I rule out, different parts of the stack? And what we give you is a different view of that data, sort of a swim lane view just to compare the different peers. So if I look at the web server and the app server and say, you know what, I understand that there's certain metrics off the charts, overall system health. What are they all misbehaving, or are they behaving correctly? And we see instantly that the web server is kind of chugging along, steady state. The event volume is normal. Even though the latency is high, it hasn't necessarily spiked in terms of activity or dipped in terms of activity, but there's a clear difference in the application server. The application server is not very chatty, and then all of a sudden there's been this huge spike at the same time. So from here, what we really want to do is dive into the data that's actually underlying this, this very specific range of just a few minutes of when this issue initially happened to see what triggered it. And so we have access to all that raw data because we're collecting the metrics and the log files. We're collecting all the events. We have sort of the full fidelity of data stored for as long as you want to keep it. You can basically just pull up the data view and say, okay, well, show me everything that's going on. Time align it, so everything is kind of interwoven from a time perspective. Give me authoritative information, my locations, my host names, my services, and you can actually narrow down your search visually, right? This is very clear on this chart where during that time period there's an issue with the application server. You can highlight that and actually just zoom in to visually search through that raw data. You don't want to be looking through millions of lines or even thousands of lines of log data if you can look at a handful and have that really identify where you need to focus and solve this problem much more efficiently with a visual search. And really, indeed, when you actually zoom into that and narrow it down to just a handful of events that started happening, you can see, something that would kind of catch your eye when you're kind of in that DevOps mindset, that there was a deployment of some beta code. All right, and so all of this very likely traced back to an issue where someone probably pushed beta code to an app server. That beta code may have had some debug logging in it. It may have had sort of a bug related to database access, causing the app server to thrash, causing latency to spike on one of the web servers. Within a few minutes of looking at the data from different angles, you've gotten to the likely root cause of the problem. So really the process here is a combination of a system that is helping you identify, sorting through all the data that you're collecting and identifying where are likely issues emerging that you need to pay attention to, a visually guided search, so you're not brute force having to type sort of magic incantations that, that you know ahead of time about the infrastructure. You may not know this infrastructure as well. This may be a new part of the system. The system will still have the same visualizations and still shows you all the related metrics and events and event volumes of the data and can guide you through that. Narrow that down into really the critical events that are likely the root cause or the initial cause of the problem, and then identify that root cause, in this case, an incorrectly deployed beta release. So let's kind of give you a taste of what's possible with Rocana Ops. If this is really interesting for you, happy to show you this on your data, your infrastructure. It's very quick and easy to get set up and running. We found it's extremely impactful for people to start shoving their own data in and seeing things that, that they haven't seen before. And in fact, what I want to do with some of the time that's remaining before we kind of open up for any questions is walk through a few customer stories, how people are using it. One customer, and I'll highlight this one in particular, and then cover some of the others. This is a financial services company. They're using a current market leader in the space. They have a few different solutions for operations. They're at about the sort of 3 terabyte a day data volume limit, and it's straining on their system. And in particular, when we look at their problems, they have capabilities to trace, say, transactions from their website to the mainframe. The application performance management solutions work well when everything's fine. It's when errors happen. And in particular, they're very sensitive to customer experience, right? From a financial services perspective, the last thing you want to see is an error when you're trying to do a transaction with your financial services institution on the website or on the mobile app. And so those are really the critical aspects of their IT operations that they need to get a handle on. And so the problem really comes down to being able to get at the root cause of full stack issues. They don't know where the issue is going to be. The system they have today degrades from a performance perspective as they fill up the disk, so it really doesn't scale from an access perspective. And so the more data they keep in the system, the slower it gets, which obviously is kind of a disincentive to keep lots of history data, which means you may miss a particular issue. You may not be able to go back and compare past performance. As a result of that, they also can't really onboard a lot of new sources of data. The network data doesn't go into the system. The application data doesn't go into the system. A lot of infrastructure data doesn't go into the system. And part of that is that the costs are directly tied to data volumes, which are unpredictable. They have to pay depending on how much data they're collecting. When they get a spike in activity, all of a sudden the bill for the month is higher. It's very hard to budget for that. And it also, if they do it too often, the application stops functioning. It's really a messy scenario when you're talking about quality of performance and experience for financial services site. And finally, the operational and business data that they wanted this is delayed by over a day. They really can't see data as it's happening. That's because data is getting collected in a proprietary store. They don't have direct access to it. And trying to get the data out actually further degrades the performance because those are just queries against the system. And so you have a system that's kind of a vault where you can only fit so much in order to actually be able to pull data out. As soon as you start shoving more in, it starts cracking at the seams. What they've been doing with Rocana is collecting data from multiple data centers, aggregating logs from different systems. They're able to reliably collect from geographically remote sites as well, whereas before they really had to have siloed systems. Now they can shove it all across to the data centers where they want to collect the data. And what they end up with is effectively a single source of truth for all of their IT operations. Any information that they need authoritatively, what happened, when did it happen, is it related to the web experience? Is it related to network performance? Is it related to application performance? That's all within one system. And what they're able to do is overall just kind of reduce the mean time to recovery from different problems. The faster they can identify where there's a particular issue, the faster they can recover and create a better experience for their customers on their web properties. A very similar setup for another customer. This is a gaming company. They operate globally. They have millions of users online at any given point in time. And what they realized is they really needed lossless data collection. Sampling the data really didn't give them enough insight because they didn't know if they were missing samples or were missing views of the data that were relevant to particular usage from one gamer or from a collection of gamers. Because this is real-time gaming, the data needs to be available in real time. It doesn't add value if it takes hours in order to figure out what happened. The users have already left and moved on to something else at that point in time and had a bad experience. And so the result of pulling this data into Rocana and having access operationally is overall improved gameplay. They can respond much more quickly to issues related to their infrastructure that affect gameplay. At the end of the day, it affects top-line growth. You get more money when people are spending more time, when they're happier with the game quality and the game experience. And they're able to safeguard against security issues and identify potential hacks into the system. If there's a spike in a service, we saw one incident where there was anomalous behavior related to one of their network services. And that spike showed up very clearly. Diving in, there was a misconfiguration on one of the servers. Someone was trying to penetrate the box. They were able to shut that down, block it off before someone actually got in. So having that real-time visibility and response, even if you aren't expecting it, even if you don't know what's happening, it's something that they're able to do with Rocana Ops. And then just last one I wanted to talk to a little bit is a large retailer. They have lots of physical locations, many sites where they have data they're collecting from their stores, from catalogs in the stores, from people who are helping customers as well as the point of sale systems. And they're actually able to pull that data in and see what's going on within their infrastructure, and this includes physical store infrastructure, ready for query in less than a second. Right, so that data gets in and shows up in Rocana Ops and gives them visibility into what's actually going on, basically as it's happening. They can identify issues with high transaction loads. They can identify issues with latency. Ultimately, it's people's ability to find what they're looking for and have a good experience paying for it and going home and using it. That's the success for this retailer. And from an operations perspective, they now have the capability to see that across the entire stack. So I hope this has been interesting. This is kind of an overview of the space, the problems we saw that led us to founding Rocana, and some of the capabilities of Rocana Ops. As I mentioned before, really you start to get the value of this when you start seeing your own data in it. If you are not collecting all the data that you need, if you're having trouble answering critical questions around utilization, around efficiency of infrastructure, around potential breaches or hacks into your system, if you don't have those answers, the answers are actually in your data. You can get at them with Rocana Ops. Send us an email or give us a call. We're happy to spend some time with you using the product and looking at your data with it. With that, we have some time if there's any questions about anything related to Rocana Ops, or the space.
Thanks, Omar. If you do have questions, go ahead and send those over via chat. We do have some questions. Tom, your line is open. You can go ahead and start asking us as you see fit.
Yeah, so I think the first question I have that came in is, you talked about reference data integration. Can you give a couple examples of that, please?
Sure. So there's two common ones. Some of the data that comes in is not necessarily mapped accurately. Infrastructure is messy, so people will have mappings from specific IPs to hosts, from abstract host names to types of hosts. You know, if it has this IP range or this identifier, it's a web server. Call it a web server, tag it as a web server. And similarly for things like blacklisted IPs, if there's IP addresses and you have a reference table where you want to identify a range and flag them based on a sort of a changing data set, You know, Rocana is not going to magically know the IPs that are good or bad. They can tell you which ones are acting weird. But if you have that data set from a blacklist IP provider, you can pull that into the system and basically have it do that lookup and annotate the data as it's coming in, or update those annotations as you get new reference data sets. Does that make sense?
Yep. So you mentioned in there, and this ties to another question we got about Rocana can identify things that are acting weird. Can you talk a little bit more about your anomaly detection mechanism?
Sure. We spend a bunch of time looking at different machine learning algorithms. If you spend time with machine learning, if you're familiar with data science, it's not a big hammer. You can't just throw algorithms at data and hope that you get meaningful results out of it. There's very specific algorithms that we've identified and tested against data from real data centers that identifies basically think of it as changes in time series. So it is a regression class algorithm, but it's basically designed to look at patterns in slices of time series and effectively identify. You can almost think of it as when is the first derivative change. So when has the overall activity for a metric or for something like event volume deviated from what it's been doing recently, as well as it's been doing at a large time range, and we can basically service either of those.
Cool. And there are two questions that came in related to one slide. They were kind of the architecture slide. One was, what are the hardware and software requirements for running Rocana?
Yeah, and I'll jump back to one of those slides. So Rocana runs underneath all this. All this system is open source software. It runs on the Hadoop stack. Typically, you can run Rocana on your laptop. You're not going to monitor 100,000 web servers on your laptop. So you need a small rack. Start with 5 to 10 machines that are running a standard Hadoop distribution. They have a system called Apache Kafka, which is the event data bus underlies that. The data gets stored in HDFS. It gets indexed in Lucene and accessed using Solar Cloud. We use SQL on Hadoop capabilities to access Parquet files. So those are the types of software deployments. And we actually have, I think, some more information on our website and our docs about sort of a typical getting started setup. But it's what you'd expect for a basic Hadoop deployment, Hadoop distribution deployment.
Great. I have, just so you know, about 3 more questions here that came in. The next one is, follows on to that architecture slide, and it says that sounds like you have some complex event processing capabilities. How do you compare yourselves to those tools?
It's a very specialized event processing capability. So if you want to do general purpose CEP, there's a bunch of great solutions out there. Some of them use similar architectures. They use Kafka. Some use different ones. You can program lots of capabilities. Some you can get down to microsecond level. This is, think of it as CEP designed specifically for IT operations for large-scale data centers. And so it's millisecond, not microseconds. The transformations are a library that takes a configuration that allows you to look at single lines of events, pull out information, aggregate across multiple lines of events. And it's a very simple configuration designed to handle the range of things that happen in a typical data center. But it's not a general purpose CP solution. If you need to connect with one, you can actually plug one right in and take the full feed or take a subset of feed.
Cool. And I'm going to combine 2 questions again into one. These are the last 2. They're both pricing related or availability. So the question is, if I wanted to take a look at it, how do I get my hands on it? And, how much does it cost?
The answer to both of those is give us a call. We just announced the product, so we are spending some time with people who are interested one-on-one, making sure that this really is a good fit for the problem they're solving. Rocana Ops doesn't solve every problem under the sun. It solves all operational problems. Drop us a line. Happy to talk to you about how to get the software set up, installed, and taking a look at it. From a pricing perspective, we can share that as well when we get on the phone with you. It is per user pricing per seat, so it doesn't matter how much data you have. It depends how many people are going to end up using it, how much value you get out of the system. That's kind of what you pay for. And pricing starts in kind of the low hundreds of thousands per year for groups of 5 to 10 users. If you have a handful of people running 1 or 2 data centers, it's very cost effective to license.
Okay, and the final follow-on in the same domain is about can we run Docker? Can we run in a Docker Compose setup or on a notebook? Compare and contrast a little bit. Elk as a comparison point.
Yeah, you can. You absolutely can. I mean, you can download and install it locally. We run all of our infrastructure in the cloud, and we monitor our own infrastructure with Rocana. It also runs in the cloud in virtualized environments. We've built Docker containers. I don't know if we've started deploying those internally yet. Some of the systems are more sensitive to quality of service than others, so we can walk you through the specifics. The web application, run it anywhere. The Hadoop services, you do need some I/O and memory guarantees. Kafka is sensitive to CPU availability. So different parts of the system you may be able to run on virtualized or in containers or on smaller machines or larger ones. As a general rule, if you run everything on the same system on real iron, it just installs and runs. But if you want to start playing with kind of tuning the quality of the services, the underlying infrastructure services for different components, we can walk you through that. And sorry, there's another part of that question that I forgot.
The second part of the question was just a little bit about comparison to the Elk stack.
Yeah, so if you look at the Elk stack, all those components exist. We didn't happen to use the Elk components, but you think of Elk as sort of the building blocks that you could use if you spend a whole lot of time to try and build something like Rocana Ops. And we've talked to people who've tried and kind of decided that didn't make sense. They'd rather just use Rocana Ops. Instead of Elastic, it's still Lucene indices, but we use Solar to query those because of the HDFS integration. We ended up not using Kibana. There's different visualizations that aren't available in Kibana that are very useful. Because we can control them out of the box, you actually get this kind of view. I'll see if I can jump to an example of this. Right, we can show you this view of the data, and you don't have to do you don't have to do anything. You install Rocana, and it will tell you, sort of the visualization is already integrated with the analytics, and the agents actually are much more optimized than what you get as something like Logstash. They run Linux and Windows. They're statically linked. You can resource constrain them. So if you want to run them on tens of thousands of web servers and tell them you get a few megs of RAM and a fraction of a core, don't screw with my web server performance, they do that. And they forward. They can forward the data over secure pipes back to the event data bus. So it's just maybe the very best way to describe it is you could probably take Elk and spend a whole lot of time trying to build this. You could use the components that we ended up using, install Rocana Ops, and get it within a few minutes out of the box at sort of enterprise grade and scale.
Okay, and that is the end of the questions.
Thank you, everyone. I hope this was informative. And as I mentioned before, if you have more questions, if you want to kick the tires and see what this looks like with your data in it, give us an email or a call. And Michelle, I'll hand it back over to you.
Thanks, Omer. Thank you so much, and thanks to everybody who was on our call today. Thank you, Tom, for your very great questions. Everybody, have a great day. Thank you so much.